Solenoid. A solenoid can be made by closely winding a number of turns of the insulated wire to form a helix and connecting the free ends to a battery. The magnetic fields of a solenoid can be demonstrated by passing an insulated wire through many holes in a cardboard, as in this figure. The ends of the coil are connected to a battery and iron filings are spread on the board. When the board is tapped, the filings settle round the solenoid to form a pattern of magnetic field on the cardboard. When pivoted magnetic needle is brought near the end A of the solenoid, we will observe that the north pole of the needle gets attracted towards A and the south pole is repelled away. Similarly, the south pole will get attracted to the end B. Thus the solenoid acts like a bar magnet. This end has a south pole and this end has a north pole. As the current flows in the clockwise direction, the end A acts like a south pole, and when viewed from the end B, the current appears to flow in the anti-clockwise direction. It acts like a north pole. This kind of rule can be called as clock rule. If we place a small magnetic compass needle inside the solenoid, we will notice that the magnetic field lines go from south pole to north pole. So it will move from south to north. Thus magnetic lines form closed loop. Inside it will move from south to north, outside it will move from north to south. The strength of the magnetic field can be increased by increasing the magnitude of the current, then by increasing the number of turns of the solenoid, or inserting a soft iron core into the solenoid. If a large current of several amperes is passed into the solenoid, a powerful magnetic field is obtained practically everywhere inside. So, a long solenoid can be used for making permanent magnets such as bar magnet. And one end of the solenoid will behave like a north pole and the other end will behave like a south pole. An electromagnet or a temporary magnet can be made by winding solenoids in opposite direction around two soft iron cores A and B. The lower end of A acts as a south pole, whereas the lower end of B acts as a north pole. Because if we will look at this phase, here the current is moving in clockwise direction, therefore this end will behave like a south pole. And if we will look at this phase, the current is moving in anti-clockwise direction, therefore this phase will behave like a north pole. This rule is called as clock rule. So by using clock rule, we can find out which end will behave like a north and which end will behave like a south pole. Electromagnets work on the magnetic effects of electric current. Electromagnetic devices are used in a variety of applications in homes and industry. In communications, for example, numerous magnetic relays and telephone receivers are employed which contain electromagnets.